This video shows several examples of how probability rules work. When we say probability, if you look at this notation, you'll see that I've got the probability of an event, we'll call it event E, is equal to 0.25. And I've got another probability, or another event rather, called F, whose probability of F is 0.45. So let's go off and try to find a few things. And this is coming from a section in our book that has to do with probabilities, and especially something called the addition rule. So maybe I should throw that up here first. The first thing we should know, and that you should remember, is something called the general addition rule. And what's applicable here, right, is we call it the addition rule because we're going to use addition anytime you see that word or. Right, that's when you know that you're going to be using addition, as opposed to there's something also called the general multiplication rule. But anytime it's addition going on, we're going to use the word or. And what's really happening here is, maybe I should draw a little Venn diagram picture. Okay, this is we call a Venn diagram. And I hope you see that, look, I have two events, event E and event F, that overlap a little bit. All right, and in this case, this little section right here, where they both overlap, is what's considered my AND. It's considered the probability of E and F. So this portion of the addition rule is the overlap. I hope you see. Okay, that's where these two intersect each other. So the addition rule, basically, the general addition rule basically says, find the probability of E, add that to the probability of F, and take away the probability of E and F. That's where they overlap with each other. Okay? So now that we know the addition rule, let's go off and try to find this first example here. Let's find the probability of E or F if we know that the probability, right, if we know that the probability of E and F is equal to 0.15. So using that general addition rule that we just saw a second ago, it says, hey, the answer to this, right, so the answer to this probability of E or F is equal to the probability of E added to the probability of F minus the probability of E and F. And we know this. We know the probability of E. They gave us that at the very beginning of the problem, right? So this thing right here is 0.25. We know the probability of F. They gave us that at the very beginning of the problem, which is 0.45. And we're going to take away this AND where they overlap. And we know that too. They overlap with a probability of 0.15. So this problem is really just a simple, hey, let's work this out on our calculator, and I hope you see that it comes out to be minus 0.15. I'm just doing this here on my calculator, and I'm getting an answer of 0.55. Right, 0.55. So there's the answer to that question. Now what's interesting is we could change this question around a little bit. Right? We could change it around a little bit. If this time we say, hey, can we find the probability of E and F? Right? What if we ask it this way? Let's find the probability of E and F if we're told that the probability of E or F is equal to 0.6. Well, it's the same formula, right? It's the same general addition formula, which again looks like this. Probability of E added to the probability of F, take away the probability of where they intersect. And I hope you see that this time, this is what we're looking for. Right over here, this is what we're looking for if we know all of these other things over here. They told us the probability of E or F is 0.6. That's this thing. It's almost like saying, hey, here's the answer to all of this stuff. And we'll use the same probabilities of E and F as we used before, which was 0.25 and 0.45. But this time, we don't know what this is. All right, maybe I'll call it, how about we call it X for now, right? Since I don't know what it is, I'll just call it X. So if I was to just switch over to algebra for a second and ask you, right, if we were to try to find out what x is, the algebra here, I hope you see, is how about we add x to both sides? In other words, let's bring this term over to the other side. I'm going to move this over here to this side, becomes a positive x, and I'm going to take away 0.6 from both sides and kind of move it over here. Right? So now on the right hand side I have 0.25 plus 0.45 minus 0.6, and now if I work all this out, I'll get the value of x, and that value of x is the probability of E and F. Alright, so working this out here on my calculator, let's see if this works out here. I've got 0.25 added a 0.45, and we're going to take away 0.6. Let's see if we can slide that over so you can see that, and that comes out to be 0.1. So there's my total answer for this one. Where they intersect in this case is 10%, right, or 0.1. So I hope that helps. Maybe I should show just maybe one more of these examples of how things are mutually exclusive or not mutually exclusive. Here, take a look at this one now. How about using the same numbers here, right? How about using the same numbers? We ask, find the probability of E or F if E and F are mutually exclusive. Alright. Another word for mutually exclusive, by the way, another word for that is that they are disjoint. Perhaps your book uses that as well. Alright, disjoint, another word for mutually exclusive. Well, if they're disjoint, then this is the picture going on here, right? The Venn diagram would look like this. Here's E, and here's F, and they don't cross each other at all. They don't intersect, and oh, that's a terrible looking circle there for F, but look, they have no intersection whatsoever. So this is going to be pretty simple. You simply take the probability of E, which in our case was 0.25, and you add it to the probability of F, which in our case was 0.45, right? And using the general addition rule, we're just going to add those two numbers up, right? So you want to find E or F, it's simply just add these two numbers up minus where they overlap, right? Where they overlap. But did they overlap anywhere in this picture if they're mutually exclusive or disjoint? No, they don't overlap at all. Therefore, it's really just the sum of these two probabilities. You can think of it as minus 0 if you want for where they overlap, but you don't even have to do that. So if they are mutually exclusive, if they are disjoint, it's a simple matter of just adding up 0.25 to 0.45 and getting an answer of 0.7. There it is. So if they are mutually exclusive, there's our correct answer of 0.7. Hope that helps.